asked all the governors to wear a mask, and put a requirement out there, and some of the governors were like, that's a personal decision. I'm like, yeah, well, you might die because of that personal decision. We've been in it 9 months. What's another 9 months? Just get through it. Once the vaccine's out there, hopefully this will stop and we can go back to our real lives. But it's pretty amazing that they actually came up with a vaccine within almost less than a year. You know what I mean?
I
So,
know.
did you see about the requirements for the vaccine, though?
No.
It has to be stored at a negative 97 Fahrenheit.
Great.
Yeah, so this is not something you can just carry around in your back pocket. And if you do get the vaccine, make sure they warm it up because you don't want them injecting it in you. Hey, I got the gloves and I'm injecting it.
Oh, Lordy.
Go.
Hey, I'm gonna go hop over to another meeting, John. But thank you very
Hey, I'm
much.
gonna let you go. Hey, thank you, everyone. Have a great day, and I'll talk to you soon.
Thanks.
Bye.
Hello, Prashant. This is Pragya here. Hello, Prashant, or anybody from the organizing team. Can you hear me? Hello, everyone. So this is Pragya here, and I'm presenting the 1 p.m. EST session. Is anybody from the organizing team has anything to add before I start the presentation? Or should I
No,
just go ahead?
this is Tim. I've already got you set to record. You can go ahead and start. Thank you.
Thank you, Tim. Appreciate it. Can somebody confirm they can see my screen as well, please?
Yes, I can see it.
Okay, perfect. Thank you. Hello, everyone. This is Pragya Nayak here. I function as the Chief Data Scientist with Hitachi Vantara Federal. I hope you have been having a nice day hearing all the wonderful presentations so far. I have been. I've been listening to the various presentations and learning a lot about Azure, Databricks, and all. My talk is a bit more conceptual and just making sure I can put the video on. sorry about that, is a bit conceptual and considering the various analytics products that I work on, I've been seeing a theme emerge, and in terms of usability of these analytics products, and that got me interested in looking at what are the underlying design principles around it. And this theme emerged of low-code self-service data analytics. Before we get into that, a quick introduction on my experience so far. I have over 20 years experience in software development and data science. My data science journey started when I started working on my PhD at George Mason University. I do run a couple of meetups in the local area, which are on a hold at the moment, but I'm looking forward to getting them started in the new virtual world in a more active manner. There are a couple of presentations I have given in the past. There's one coming up actually next week, which will be talking a little bit more on deep learning, a different topic from this one. Hopefully, some of you can join me there. I do contribute as reviewer for a couple of journals, and I'm part of certain technical organizations, associations. So the way I'd like to lay out this presentation is just cover a little bit on what does low-code application development mean, and then look at two example data sets that I have taken. One is a primarily structured data, another one is an unstructured data, and looking at two applications which I work as part of my day-to-day job, and look at how they support this whole low-code and self-service analytics concept. And also tied together with the Azure Analytics and Azure Open Data Platform, which I haven't had a chance to do in more detail, but that's definitely one of the next steps. We'll be getting onto that. So before even we get into low code, let me just pose a quick question. Think about it. Do you fear data and its complexity? And what is the reason for that? When all of us are here because we all work, likely we all work in data presently, or we are looking forward to working with data. Data has its own, when you're working with data, it has its own unique challenges and problems which need to be addressed. And they come in different stages. When the data is being collected, that has its own set of unique problems. During transformation, like figuring out which particular data is of relevance for us, what additional data needs to be added, as well as the steps involved around it. And then the prime focus of any time we are working with data is we're trying to develop a solution which does not have a straightforward, let's say, a mathematical formula which can be used, but you're trying to leverage existing data to get a better handle on that. Now, these different things that you may have thought of, one way in which that complexity associated with data handling, you could consider data handling as both data engineering as well as data science, is the construct of low code or no code, as minimal code as possible, just so that you can focus on the problem resolution rather than configuration, environment, etc. So low code is an effort in that direction. As I mentioned, it's about being minimal coding or no code. But what does that mean? If I don't do coding, how am I solving my problem? You are doing coding, but it's in a more visual manner where somebody has already gone in and built certain building blocks for you. Some of the most commonly required building blocks that are required in a data uh, handling problem, that somebody has taken the time and effort to create them for you, and you are reusing those components to formulate your solution. As you can see in this screenshot over here, it's definitely much more easier to explain to somebody who is not from the programming world, as well as even if I'm from the programming world, when I'm looking at any code, even sometimes when I'm looking at the code I have written myself, then it takes me some time to figure out what were the logical steps around it. And this way of working using these type of building blocks is particularly attractive or particularly useful when you're working with a data-based, data processing-based solution space, just because it lets you do that type of buffering. It it inherently provides you the capabilities to do the data buffering, doing the data management, and the whole continuous feedback, as well as processing them in a streamlined manner. So there's a flow-based programming which is happening here, and there's a whole field dedicated to that actually. So as I said, it's definitely easier to look at a flow-based code rather than looking at written out code as well. This enables self-service. What I mean by self-service is somebody, again, minimal coding, somebody is given the options or the data attributes that are available in a given data asset, and they are able to do their what if analysis, develop their visualizations without having to write a line of code. Agreed that there will definitely be instances where there'll be something very specific to your project needs. At that time, what these low-code application development environments provide is the flexibility of being able to add those requirements as building blocks, as these black boxes akin structures, which you only need to provide your configuration information, and you are getting it incorporated into your data processing logic. So typically, these platforms will have an SDK that you can use to enhance and add custom features that you need, which are very specific to your needs. As you can see, it's simple code that is both easy to explain as well as understand. And just because of this, there is a minimal specialized training required, as well as the learning complexity associated with it is reduced. So flow-based programming is not something new. It has been around. It was first monikered by J. Paul Rodko Morrison in the late 60s. And when you think of flow-based programming, it's typically in this type of a structure where there is a flow associated with it, where each of these connections, you can consider of them as a buffer, where data is being buffered while waiting to reach a certain capacity, or you could, if you have the configuration capability saying that do not buffer, but send it as and when it's available or within a certain time frame, that's when the data is moved on to the next step. So this kind of makes your processing, not just your processing logic easier to understand and follow, but also debugging becomes easier. Also, you are breaking out your processing into these black boxes or building blocks. Um, so some of the, so it's a metaphor for data processing factory. You could think of it as networks of these black box processes. You have been given a black box, you know what is the expected configuration, and you know what is going to be generated out of it, and based on that you determine the downstream processing. There's communication via buffered data links. It's like a assembly line for data processing, and each of these blocks are doing their respective processing in an asynchronous and concurrent manner. One alternative term which is commonly used is data flow programming. So in terms of those black boxes, one of the products that I work with, Pentaho, for example, provides these type of a varied number of commonly used data operators as well as data connectors, because you need ways from these products to be able to connect to the data source, as well as being able to uh, connect to the data source to read it, as well as being able to connect to data sources to be able to write out whatever processing you have done and the final outcome of your processing. So that involves input operators. So that will be a number of different types of input data sources which it needs to connect to be able to read data or read reference data, etc. Similarly, there'll be output operators which you can add as part of it. So each of these which is being listed here is one of those black boxes. Input is likely the very first step of your workflow or the data flow logic we were seeing in the earlier slides. So input is likely to be the very first one, and output is likely to be the very last one, typically, but you may have a certain workflow setup where there may be further operations also happening. And particularly and specifically for reading and writing, that's the reason you need separate input and output operators provided as part of the platform, so you can use it in your data flow. you're doing your input and output. In between, you're trying to do a lot of data manipulation, data transformation, etc. So you need operators for that. There's certain very common needs which literally most data scientists, data engineers will need. Those have been pre-built and provided as part of the product. And this is kind of the standard in most data analytics products which have this type of low code support. So you can see there are a couple of very interesting transformations here. For example, concatenating the fields, adding a checksum. Then there is like replace and string. So in a string, if there's a particular text I want to replace everywhere with something else, I would use this operator in that case. Sorting the rows, the select values is a operator which would let you change your metadata. For example, you have written a field which is a string, but you know it holds numeric values, but you need to do certain cleanup before you can convert it to a numeric value. So at the point of your data flow where you are ready to do your data type change from string to int, that's where you would use an operator like this. So you're essentially changing your metadata. You may be changing the length of a string, changing the data type, changing certain other attributes associated with it. You want it to be nullable, a field to be nullable. Those are the type of things which are in this particular product, what the select values does. So those are some of the examples of standard operations that you will literally want to do with your data anytime, and they're supported. Definitely SDK is available so that, as I mentioned earlier as well, let me just repeat it, that if there's a specific custom need that you have, there's an SDK via which you can add a separate similar operator in order to provide that feature. So what is the positive impact when you use a low code based environment? It is very obvious. The development time is reduced, or development time is more effectively used, because you could start off with a rapid prototyping as early as you get a good idea as to what is the purpose of your data analytics effort. The code becomes easier to maintain and reuse because you can kind of see it's a component oriented architecture, as well as the code is more easily explainable just because it's more visual in nature. Then of course the performance tuning becomes easier as well in these type of platforms, because it supports service oriented architectures and multiple cores are more effectively leveraged. You could determine how many multiple threads you want to run for a particular one of those black boxes that you had. You could have multiple instances of those running, and that's effectively taking care of your um, making maximum use of your underlying infrastructure and your platform available for you. Definitely, everything leads to eventually communication, which is very crucial when we are working on a software project. And this helps the communication between developers, end users, as well as the management, as everybody has easier access to what is happening when certain changes are being applied, and the logic behind a data processing. For example, you may be looking at your data in this form, and your code is literally sometimes in this form as well. It's a more of a textual file where you have your Python code, R code, etc. laid out. However, instead, if you show them a chart of this nature where they are able to do more what if analysis, apart from obviously the workflow, the data processing that I had shown in the earlier slides. So these are the kind of ways in which there's more rapid communication happening between um, different stakeholders of a given process. And this kind of looks similar to Power BI based visualizations. So just want to highlight that this is just one of the other similar self-service analytics application. I think one thing that I would like to just highlight from the earlier presentation was it ended up saying solve more complex problems. So the positive impact of low code based platforms is that you get access to be able to solving your problem. You're focusing more on solving your problem rather than um, uh, handling the bells and whistles around the problem resolution process. I have not been checking the chat window. If there are any questions, please let me know. Excuse me. So let's quickly look at what essentially we mean what by low code application examples. Graphs and networks are typically the underlying concept where you have something moving from one to the other and there's a dependency among the different components. And that is what you would see in those black boxes and how they're connected with the buffered connection. So there's kind of a, you can imagine it as a graph. There's a workflow associated with it where data is moving from one point to the other. And also you could consider these various visualization and infographics apps which come with pre-built charts and graphing options, which so that you are not writing the the code underlying it, but you're leveraging these charting options which are already provided to you, and you're determining what is the data I want to look at and what visualization makes more sense to use it. And at times I've seen where based on the data, the platform may recommend even the visualization which makes more sense for it. If your data is something where a box plot does not make sense, like you have, let's say you have like textual data and you're trying to get a box plot generated from it, it'll typically be grayed out. So you don't even have access to run it. So these are some of the low code application examples that I can think of. Even data analytics products, which these are the two I'll be using in my example in the following slides. So just looking at a visualization on infographics app, the support you get is that you get access to all the fields which are available in your data asset. So for in this case, for example, it's the data set is related to injuries, and there are these various fields which are part of the data, and they are being made available for me. So you are not having to run a SQL query in order to get the data before you can run it. So this is an example in the whole low code construct. One other thing is you get a chance to just drag and drop the respective fields that you are trying to get an answer on. You have a specific problem that you're trying to answer. In this case, I'm trying to understand the patterns in the injuries which led to injuries versus loss of life. And this is the way I'm going about it. I've dragged certain fields and then I'm like, I want to split them out by the casualty and or the injury and get a better understanding of it. And then I could add certain filters on it as well, so that I'm limiting the scope of the data to whatever is most relevant for my specific question that I'm trying to understand. This is just as I was looking and researching on the flow-based programming construct, it was very interesting to see that there is a JavaScript language which is entirely based on the flow-based programming environment, no flow. I haven't checked it out myself yet. That's definitely in my next to be read or to be understood list. But I did find it interesting that there is a specific language which has been generated based on the flow-based programming construct. Why do we need these type of data analytics applications, etc., particularly in the governance space? Just trying to lay the ground here as to why is data important? And I work primarily in the governance space in the federal government. So something that inspires me is the federal data strategy, which is instituted in 2020, and um, it's a multiple year effort. So what it does is it recognizes data as a strategic asset, and they have designated certain officials whose primary responsibility is making sure that data is being treated as an asset, and um, it is being leveraged in the various missions and the vision of the agency itself. And it reinforces the recommendations of the Evidence Act. More information related to this is available in this particular link mentioned here. Now, I mentioned it's based on the Evidence Act. What the Evidence Act says is that any type of policy that is being formulated, attempt should be made to make sure that it is based on data that exists. So it's the foundations for evidence-based policy making. And that in turn has also led to the further growth of open data. Open data is an open data policy that modernizes the way government is collecting and using the data, as well as making it available to the general public for dissemination and usage. Open is also an acronym which stands for Open, Public, Electronic, and Necessary. So that the data is being provided in a machine readable format. So applications, to be specific, data applications can be formulated leveraging those data. There are various websites which provide more information in this context: challenge.gov, search.gov, code.gov. I definitely recommend you to check them out. I'm definitely using the data. One of the open data platforms is the USS Spendinggov. It tracks the federal spending information. If you go to ussspending.gov, you get insight into based on quarter by quarter spending, as well as a couple of other easy access. Additionally, the data is also available for download. So if you are looking for data, I would definitely encourage you to check this out and see if there's any data applications you can think around it. There is also data.gov, which I think I mentioned earlier. If I didn't, just want to repeat that as well. These are two of my favorite sites to look up for data. Anytime I'm trying to prepare for a demo where it has to be something which is publicly available data. And in the process, sometimes I've had some really interesting um, analysis and a better understanding of the agency's purpose itself. So as I said, I definitely encourage you to check it out. So ussspending.gov has this um, related to budget functions. You see the breakdown and you can see it by quarter, and all that information is available there. However, the data I used for the demo that I want to show you, or I've taken certain screenshots. If time permits, I'll definitely want to open up the application and show that to you as well, is the fiscal data. And this data set has been cleaned up. The metadata has been provided. The data description has been provided. So it's a very clean data that is available for use. So that definitely inspired me to take a look at it. It's the savings bonds value file, and we'll get onto that. What it represents is it's the excuse me, it's the redemptions table of savings bond. That is, if a savings bond was issued in a particular year, if it is redeemed or redempted, I don't know which is the right word to be used for this. So whenever the redemption happens, what is the price associated with it? Or what is the value associated with it? So it gives you a neat little data set, and we'll get onto that next. The data is being made available to you in CSV, JSON, and XML, so you can use your favorite way of handling it. I'll also be using the low-code based data engineering platform that I'm using to be able to look at all the three data sets and look at the differences and just play around with it. And you can see that this data is from 1992 through 2021, and it's updated semi-annually. There's a data dictionary which is provided, which is neat. And then you can, based on what you're trying to accomplish, you can just either get 1 year data or all the data, or they also have it via 5 years or 10 years. So this is the link for that. Definitely encourage you to check it out. There's an API quick guide. You don't have to download the data. You can connect to it via the APIs and work with it, as well as they have mentioned certain related data sets. So that's definitely one of the things I want to do as a next step on figuring out what are the interesting ways in which this particular data set can be combined with that. So in terms of, so I was using the Pentaho application for the data engineering aspect as to reading the CSV file and then writing it out to a Postgres table so that I can do further analytics-based visualization on the data which is available. So it required a certain amount of cleanup, not too much. There was for the different months, they provide the values which associated with the different months. When there is no value associated with, they have used the text null in it. So this whole cleaning process you are seeing here, this block here, is for changing the different values from null to empty to actually being null instead of the string null. So that is required, and then there were certain metadata changes I had to do. As you can imagine, because this has the null value, I had to read the data, even those ones for the values as string, do this processing before I convert them back to numeric data types. And then I'm writing it to a Postgres database. Now, as I mentioned, they have both CSV as well as JSON and XML. Those are the three formats in which the data is available. Now, the CSV data ingestion gave me what I needed to do further analytics, but I did want to check out the JSON and XML just to be sure that I'm not missing anything. Is there a new field in there which likely is not there in my CSV data? You know, the general suspicion of a data scientist trying to be very sure that I'm looking at everything, I'm not missing something in the process. So JSON-based data ingestion. So there's a separate black box again, which is provided in this product for JSON data handling, which has definitely, I would say, increased in terms of how convenient it is to work with JSON data using this reader now compared to a couple of years back. So there's been improvements happening in the whole, in the various black box items that I keep mentioning about. So the data is available in this format, typical JSON file. Now, in terms of JSON data ingestion, let me just go a little bit deeper into that as to what happens. So from the if you provide the file as the input, there is a certain button you can click within the JSON input, which lets you get an understanding of the different fields which are there in the JSON data. Now, this was a very clean, it's been cleaned, it's very, it does not have any weird fields here and there. So it made it easier. But even when you have those type of like a field showing up in a certain record, but not in the others, this makes it very convenient to figure out your debugging process and understanding the data as well in the whole process. So you get a listing of all the fields which are there in each and every record within the JSON file. Then you are also able to, once you do once you select the fields, like as I've done here, these are the fields I'm interested in, then I can do a preview. So it pulls the data and shows me. That is another way I can check that it does not did not mess up any data, did not put a particular field data in some other column due to certain misformatting, etc. So those type of data understanding and cleanup is made convenient. After that, when you have selected the fields, you can see that it formulates the field path in a specific manner, so it becomes easy to look at it and review it in future. Now for XML, similarly, there is a XML reader. So what it does is the XML data was in this format, and I can see all the available fields within the XML file. It gives me a listing of that. And then based on that, I tell that I want all the values that are within the data element or data/data element, and anything within there is constitutes one individual record. So I'm able to provide that information here, saying that the loop path is this root element data element. And so from there on, it looks at the individual fields and reads the data and makes them available. And I've confirmed that all the three data being read, they have the field names are slightly different in the JSON and XML versus the CSV, but otherwise the data matches up, the number of records match up. And this was quite easy to do. It's like a couple of hours where I was able to validate the data and get a good understanding of what each individual attribute value is, and being able to do further analysis on it. Now that the data has been read into the Postgres table, I was able to connect to it. And then, as I was mentioning earlier, like this is the self-service analytics or the low code. This is also another form of low code. I would definitely attribute this as a low code. Is I have immediate access to the fields which are there in my data set, and I'm able to do my what if analysis and whatever exploration I want to do. So as an end user, I have access to the data. I don't have to write a SQL query in order to to the data or wait for somebody to generate a report for me, which can take sometimes days or months, depending on which organization or where you are working. Whereas in this case, if you have been given the permission, you are supposed to have access to the data. This makes it much more easier and convenient. And as you can see, I was like looking at if the issue year was 2000, and I was looking at what was the redemption value of the savings bond in these years. If I bought them in 2000 and then I'm redeeming them in 2019 through 2021, and then I sorted it by the month of the year as well. And I'm looking at the series code I. The data description has an information on what series code I means. At the moment, I don't remember, but it's straightforward. It's on the website. You can easily figure that out. And that may be something I definitely want to improve on this visualization so that instead of I, it should say the value. And that is again something I can potentially be able to add it over here as a new field, and add the logic to do that mapping from value I to a textual description, so that is easier for the end user who is not familiar with what series code I means. So that all is possible to be doing it here. Um, and as you can say, that does mean like you have to do certain coding. Yes, you have to do certain coding, but as you can see, the simplicity of this is that it's whatever feature you want to add, you're adding it in a more elegant manner than having to like go down to the very foundations of your code and trying to do those changes. So those are the type of things which make a low code environment more usable. This analytics. So as expected, these are all like you can see like with more time that a savings bonds is there, the value is increasing. Now, I got curious. I was like, is it always increasing for all the different types of series, or were there any other um, particular types which had like where it was increasing, then suddenly it went down? So I'll show that in the next slide. Just want to highlight that as you can see that you are able to select all the different fields that you want as part of your analysis, and then you're able to filter them, because as I said, I was interested in only issue year 2000. So that's again straightforward, where I had to just right click on the field and say filter on it, and then say that I want a list of values, and then one of the values was the one I selected, and I said use it in the filter. So that's the reason it's using 2000. But in redemption year, I wanted multiple values, so I was able to select that. That's there. And then you're able to do a certain amount of visualization or visual techniques. For example, if I was just looking at the values, yes, I'll figure out. But then as part of your low code self-service analytics, you can add certain coloring and a couple of other ways in which you can add certain more visual cues to your visualization for easier um, understanding of what is happening and the patterns and trends associated with it. So as I was mentioning, was it always increasing? Is there any particular savings bond where it went down? Now, don't ask me why it went down. That's something I'm curious about, and I'm going to investigate after this presentation. But when the series code was of type E, and I was just looking at redemption year 2021, and you can see here I'm looking at it slightly differently. On the earlier slide, I was looking at issue year and the redemption year. Here, I'm looking at the redemption year, and I'm trying to see uh, when should that savings bond have been issued, uh, and what was the associated value with it if I look at it from 2021 redemption year perspective. You can see that it is increasing till 1965. Then something happened, and 1966 is went back a little. The value reduced, and ever since I was trying to scroll down to get the further values, but you can see it has remained kind of stable from that point on. So if you understand the savings bond and you know the reason, please share them with me instead of me having to Google and find out what happened and figure this out. But definitely that's something interesting. And as you can see, this is all analysis I'm doing like in a matter of hours. I'm not, it's not like I've spent days together in order to reach this particular point. So one of the advantages of low code analytics based applications. Again, you can add your filters and the output from it as well. And you're seeing it for the different months. Another one I was looking at is like by month. So if I was going with redemption in May of 2021, based on the issue year, what is the for series code I, what was the value associated? As you can see, it keeps on decreasing. Now, this is something again interesting as to why, but with particular to series code I, that we are seeing this behavior. So again, something as a novice user of this data set, it piques my interest and I want to learn more about it. And I can just imagine what, as an expert user, what type of questions they can pose to this and get a better understanding of, or be able to join with other types of data sets and do more evolved analysis and more expand the understanding of what is happening and why is it happening. With this, let's move on to the second example that I wanted to quickly highlight. And this example is an unstructured data. That is, there are text um, data in it, which is not structured, but there's certain metadata which has already been collected with respect to each and every uh, uh, textual data that is a record. So here, a record is a paper and a research publication. By paper, I mean it's a research publication, and certain metadata has already been collected for each and every research publication, and that's provided as part of this data set. This is the COD19, stands for COVID-19 Open Research Dataset Challenge. So I did a very initial analysis with it and tried to understand how good the data was in terms of the content. Were there any discrepancies I was seeing where it's saying the data was provided in JSON, and this particular application I'll use that lets us detect the MIME type of a document. And that I wanted to verify, is it always that is being identified as a JSON data, or is it sometimes being mischaracterized as something else? So that's the specific example I was looking at. Um, and yes, when you're dealing with unstructured data, you want to deal with both metadata and text data, or in other cases, it can be where the data is an image, audio, log files. Those are some of the other unstructured data. And this application that I'm going to be covering next, that is more specialized for unstructured data. So you can see, like, in terms of the whole workflow based data manipulation or the data engineering process, this has a slightly different way in which um, it is being shown to the developer. In the earlier one, we were seeing there were multiple ways in which you could just like more of a flow based. Here it is also flow based, but it is more downwards streaming. Your logic is going down. So that's just the UI which has been provided. So there are these various things which have been provided in terms of the data connections again, which is important because you want to be able to connect to multiple types of input and output data sources. So that lets you connect to those. Just for time restriction that hitting at 10 minutes, I had kept this part brief. But if you have any questions, you want to check out this product, please let me know. We'll definitely be able to cover it in more detail. So there is the processing pipelines, which is the basic which is the data transformation logic, and workflows designer is more on terms of tuning it to specific data assets that you want to handle. For example, if I'm working with file shares, my processing pipeline will take care of the data, making sure the file name is nothing weird. It does not include any special characters. It does not include spaces, etc. In some places, that's a standard. They have that file name should not include certain characters. For example, in that case, that's the check you want to do as processing pipelines, because that's specific and it will apply to, irrespective of which file share I'm looking at, it will apply. But there may be certain I may want to break down my processing for, let's say I have hundreds of file shares. I may want to take 10 file shares at a time, and this workflow designer is the way in which I can provide that type of task breakdown and processing breakdown. And there are a couple of other functionalities available in terms of the index collection. So the index collection is like a elastic search index, and you're able to perform searches on it, because this provides you the way to perform your data processing, and your index collection will let you query your ingested data and doing further discovery scenarios using the metadata that you have collected with respect to each and every record, in this case, a file share. So the processing is in the top to down form, and there's certain conditional operations you can do, as well as each of these is a stage, and stage is the equivalent of those black boxes I was talking about. So the stages itself, they're the different categories, and there's further all these individual very specific operations or black boxes that have been provided, which you will use as part of your processing pipeline. And the search interface lets you look at the data and perform queries and do your what if scenarios analysis, look at your discovery scenarios, etc. Like in this case, I'm limiting it to the index associated with the CORD data, which has been ingested already, and I'm only looking at JSON data, so I can search that here. Then what happens is just going back a little. When I search for JSON data, it gives me the different, I can define the different attributes or metadata which I want available for my faceted search, so that they will show up here. In this case, I just content, which is a MIME type, and then I want to figure out, if I'm looking for JSON, why is text HTML also showing up? Which are the examples of that? In order to be able to do that analysis, I select the text HTML, and you can see that there is a certain example showing up. And of course, this document metadata, that is also flexible, so I can add additional value related to this particular record that can show up here. So that concludes the different demo examples. Unfortunately, we could not get onto the demo itself, but feel free to let me know if you would like to sometimes talk to me about that. One thing I'll highlight is that my next step is looking at Azure Open Datasets. There are a couple of very interesting datasets available there, as well as there are these different ways in which you can work on those data, and some of this have been covered in this conference so far. So I'm really looking forward to being able to work on these type of data applications using some of these tools which have been provided, as well as looking at Azure Analytics and the different services which have been provided in terms of analytics. Just to summarize, low-code development definitely helps everyone in the solution development process, because the design is more modular, more visual, easier to understand and follow. It definitely aligns itself to data-driven related processing. And each of these products have a domain-specific extensibility feature. So if you have something which is very domain-specific, they have an SDK where you can add those features. And anytime you're looking for data and you don't want to spend money on buying the data from some particular resources, consider open data. There's a lot of plenty of interesting data to be processed, and definitely the different agencies who make this data available, they're looking for you to contribute back and help them address some of these problems or provide your unique perspective. And it definitely aligns, this whole way of development aligns with data ops related governance, data governance. There's an emerging need for where you're doing continuous improvement of your data processing, as well as you're automating as much as possible. Anything that is repeatable, definitely it should be automated, and this kind of enables that. And talking of data ops, ML ops as well comes into the purview. So with that, I have what I wanted to, I've shared what I wanted to cover with respect to low code analytics. Definitely look forward to your feedback and any questions or any suggestions, any other interesting insights you have related to that. Look forward to chat about that. And this is my contact information. Thank you.
Thank you
Any
very
questions?
much. Thank you very much. Guys, if you have questions, just put them in the chat box or just take yourself off mute. And if we don't have any questions, go and enjoy your Friday, everybody. Thank you very much.
Have a nice day, everyone. Bye.
Thank you. Almost